Let's take a moment and go over some of the features of the Productivity 3000. One of the big ones is it's what's called tag name based addressing. On the older systems like this, when you went to program it, each input card, it would assign X's and Y's. Inputs were X's, outputs were Y's. It would assign physical addresses. And in this unit, it was octal based, so you would go 0 through 7, skip 8, 9. It was very, very archaic and very difficult to learn. Once you learned it, you had it down pretty well, but it took some time to learn it. This unit, there really is no addressing. What you do is when you go into the software, you're going to see the rack and such, and you're going to create what we call tag names. Names that mean something to you. Such as if I hook up a flow switch to an input on here, I'm going to give that input a name, flow switch. And when I write my program, I'm going to see those names in the program. I'm not going to see the physical address. So it's very user-friendly. Now, to make that work, we have to have the ability to download all your tag names into here, which it does. It has lots of memory, 50 meg. Another thing it has, what we call runtime edits. I can actually make a change to the program as it's running. So I don't have to put the PLC into program mode to change it. I can make a change as it's running. Another feature it has, which is very nice, I can break them into separate tasks. In this unit, we used to have one big, massive program. I used to call it spaghetti programming. In this one, in the software, I can create regular folders, like Microsoft folders in a window, and in those folders, I put my ladder logic that I want to execute. And I can have those folders, or what we refer to as tasks, run based on time, based on minutes, based on seconds, based on events. I control when they run. I can have them run all the time, but I can break my program into separate tasks. Another thing it does, nice feature, it auto-discovers all the hardware. Years ago, when we would use these units, if you plug things in, maybe the CPU, you had to address them yourself. Sometimes it auto-addressed them. Here, when you plug it in, it just automatically discovers everything. So if I take and put a remote rack somewhere else and plug it in, the CPU just automatically discovers it. And how does it do it? Well, it does it by itself, or you can click one button and say discover, or there's a third way. You can manually go in and say, I want these cards to be in these slots. On top of that, not only does the remote I/O system support remote racks, it supports frequency drives. So I can plug in frequency drives out there on the Ethernet network, and they just appear. All the settings that are in the drive appear in the CPU, so I don't have to do any kind of mapping. All I got to do is assign them names, tag names again. Another feature is I can hook this up to an SQL database or an ODBC database so that I can get data out of the PLC. So I can take the data from here and store it into a database for long-term storage. The LCD display on top of the CPU and on top the analog input-output cards, and the remote racks controller. The controllers for the remote racks have LCD displays on them, and I have commands in my code that I can send my own messages out to those displays. When I put the rack together, in the older systems, I had to watch how many cards I put in because the power supply in here could only power up so many cards. This was designed with a power supply that can run any cards. It doesn't matter if I put all relay cards into this rack, I don't have to worry about what power supply I've purchased because I either I buy a 120 volt power supply, a 24 volt power supply, and by the way, the 120 goes all the way up to 240, and the 24 goes all the way up to 48. So there's two power supplies I buy. I plug it in, and they power up the rack. Doesn't matter if I have all relay cards, it doesn't matter. And all the cards can go into any slot. On the older systems, certain cards had to go in slot 1. Certain cards had to go in slot 0, depending on what the card was. Another place where it'll fit is where you have data or communications intensive applications, such as a sort facility. Lots of memory storage, lots of high-speed communication abilities. So when it comes to sorting and storing data, that's where it fits.